Derivatives. What calculus is all about. If you missed my last video, go watch that where I teach you how to do the derivatives using the limit definition of derivatives, where I explain how derivatives are the slope of the tangent lines of graphs. Today, we'll be taking a look at how to take the derivative in a shortcut method for every single equation that you see. So let's start with y equals 4x plus 3. Alright, so let's take a look at the power rule. When we do derivatives, each scenario has its own rule that we'll look at every scenario here. But let me tell you this, power rule is used in almost every single scenario. In fact, I would say all your derivatives incorporate the power rule in some way. You just might not realize it because it becomes intuition after a while. So, power rule always looks at each term independently, whether you have an x or not, because every single term is x multiplied to that coefficient to some exponent, right? For example, 4 times x to the first is a term here, and 3 times x to the 0 power is one term here. X to the 0 power is 1, so we could assume that. Now, okay, I'm going to do y equals 4x plus 3 and take the derivative of that. Now, before we continue, let's talk about the notation. How do I write that? Well, for function notation, you can write f prime of x to be the derivative of f of x. Now, since we have y here, we cannot write f prime of x. I have seen notation be written as either y prime, like this, or my favorite is dy over dx, which says derivative of y with respect to x. And we'll come back to what with respect to means. We'll show that in later videos. So, y equals 4x plus 3. So I'm going to use the dy over dx notation. So dy over dx, which means derivative of this equation, or derivative of y with respect to x, equals, now let's follow the power rule. The power rule is multiply exponent to coefficient. So the exponent of x is what I'm multiplying with. So here, for this term right here, my coefficient for x is 1. So I multiply that 4 times 1, which is 4. So that's easy. Now I'm going to subtract 1 from the exponent of x. So x to the first minus 1. So 1 minus 1 is 0. So x to the 0th power, which would be basically, I'm not going to write equals, but that would be basically 4. So now, let's take a look at what 3 would be. Now, 3 does not have an x, so we can say x to the 0th power. Now, since x has a 0 as an exponent, 0 times 3 will be 0. So basically, the answer to this equation, or the derivative to that equation, would just be 4. Simple, isn't it? Now, it's your turn. Take a shot at this problem. Pause the video and see if you can do it. Okay, I hope you tried this problem. If not, just stick around. So, I have f of x here, so I'm going to take the derivative of this, which would be f prime of x. Okay, we did the easy part. Now, let's do the other side. 3x squared plus 4x to the third plus 9x plus 7. Okay, again, each plus or minus separates the terms, so this would be term 1, term 2, term 3, term 4, and now let's look at each of the terms separately. So, I'm multiplying 2 to 3, that would be 6, and I subtract 1 from that term. Next, I go here, 4 times 3, 12. Now x to the third would become x to the second. Now, 9 times 1 would be 9, and x to the first minus 1 would be 0, so that would just be 9, x to 0 is 9, plus, now x to 0 times 7 would just be 0, so we don't need to include that, but there you go, that's your answer. Alright, now let's explore product rule. Now, product rule is when you're taking the derivative of two functions that are being multiplied together. Now, so when you multiply two functions together, here I put the notation as d over dx, which means taking the derivative with respect to x. When I say with respect to x, I mean, since you're only operating on the variable of x, because you don't see any y's or z's and you're not taking the derivative of those variables, we're saying with respect to x. So that's the variable that's on the denominator. Now, whatever is here is on the numerator, whether it be y, z, or whatever. So the product here is on the numerator, so what this means is taking the derivative of f of x times g of x. Now, to do that, you have to take the derivative of f of x and then multiply that by g of x, and then add that to the derivative of g of x multiplied by f of x. So let's put that in practice. Here I want to take the derivative of 2x plus 5 times 3x plus 2. So what I'm going to do is take the derivative of this, then add that to, multiply that with this, number 2. I'll take the derivative of number 1 and multiply that by number 2, and then do the exact opposite, take the derivative of number 2 and multiply that by number 1. So let's do this. Okay, so when I take the derivative of number 1, I get 2. Now multiply that by 3x plus 2. Now, I take the derivative of 2, and I multiply that by 2x plus 5. Okay. Now all I have to do is simplify it. So when I simplify it, I get 6x plus 4 plus 6x plus 15, and then I add them together, 12x plus 19. And that's how you solve one of these. Okay, so we're doing quotient rule now. What this is basically when you do the derivative with respect to x of f of x divided by g of x, you do f prime of x times g of x minus g prime of x times divided by g of x squared, or whatever is in the denominator squared. Okay, in other words, you can say the derivative of the top times the bottom minus the derivative of the bottom times by the bottom squared. Now let's look at an example. So let's say I'm taking f of x as 2x plus 5 and g of x as 3x plus 2. Now I'm going to take the derivative of f of x divided by g of x. To do that, I'm going to follow the product rule. Okay, f prime of x times g of x. So the derivative of this, f prime of x, if we use the product rule again, we're going to use the product rule for pretty much anything. 2. That's it, because this 5 gets multiplied by 0. So anytime you have just a constant, you always end up with 0. Keep that in mind. G prime of x is again 3. So let's fill in the blanks now. 2 times 3x plus 2 minus 3 times 2x plus 5 divided by 3x plus 2 squared. Now, you can leave it like this if your teacher permits you. But if not, no worries. I mean, you know how to simplify everything, right? But I strongly suggest only doing it to the numerator because combining like terms helps you get another expression which could potentially, when it factors out, divides out with the denominator at some point. If not, you might just get a result just like mine, and that's still fine. Now, if your teacher allows you to keep it in factored form, I suggest you 100% leave it in factored form. Alright, last one of the day for the basic rules of derivatives. Now, this one is the chain rule. And this is when you have a function inside of a function. The very famous ones. So, the derivative of f of g of x is f prime of g of x times g prime of x. That's it. It's simple. So if I have something like, f of x is, let's say, 3x plus 5, and g of x is 2x plus 8. I'm going to do d over dx, so I'm going to do the derivative of f of g of x, f of g of x is, let's see. Now I want f prime of g of x. So the derivative of f with g of x inside it. So let's do f of g of x first. F of g of x is 3 times 2x plus 8 incorporated plus 5. Okay, now f prime of g of x would just be, I need parentheses here. Let's expand this out. So 6x plus 24 plus 5. 24 plus 5 is 29, so 6x plus 29. Okay, 6x plus 29, that would just be 6, isn't it? I'm going to show the expanded form here. Plus 24 plus 5, and this would become 6. So, I'm adding 6 here, which is f prime of g of x times g prime of x, which is 2 times 2, and the answer is 12. Now try these challenging problems by yourself. Now, some of these incorporate, multiple rules within themselves, but that doesn't mean you can't do it. Try them out. Well, here are my answers. How do you do? Well, anyways, thanks for watching, and see you next time.